This one is another sample question that has to do with the product rule. Might not look like the product rule, but that's because you have to figure out what your like bases are. So you can have little mini bases that are like. It doesn't mean that all this must match all of this. You can have pieces that match this. So this says simplify using the properties of exponents. We know our properties. We have product rule and we have quotient rule. On ALEKS, will also mention you can use the associative property and the commutative property. We've already been talking about the commutative property. That means you can mix these up. You can put the x's together, you can put the q's together, you can put the coefficients together. And then the associative property says that you can remove parentheses. You could put the parentheses around this and this, parentheses around this, and then keep the letters separate from the numbers. So just in case you see those directions, that you know what the associative property is and the commutative property. But for us, we just want to simplify. How do we simplify? We're going to see if we have any like bases. Before I can see if I have like bases, I got to know what my base is. So let's see. We know this 3 can only apply to the q. It's not going to apply to the x. It's not going to apply to the 4. The reason why we know that is because the first thing it touches is just the q. Now notice x didn't have an exponent. If it doesn't have an exponent, we told you, any variable, we can write in an exponent of 1. So you know this 1 will only apply to the x, okay? Because it's the first thing it touches. I'll put 2 lines here to represent q and x are different. Over here, you know that this 2 is not going to apply to this, but only to the latter. Why? Because it's the first thing it touches. Remember, we told you that a coefficient is separate from a variable. So, that's one base. And then this 3 only applies to the q. There's another base. So I have a 4, an x, and a q. I have a 3, an x, and a q. So you can see that x and x are like bases. The q and q are like bases. The 4 and the 3, they're not like. So we're going to put them in front. Why can I put these in the front? It's because of the commutative property. If you don't like this, because a lot of times I don't like putting it as a dot, we can use the parentheses and switch the parentheses to only include the 4 and the 3, because that is what the associative property is about. For the x's, x, x, the same base, so I can keep it the same like base. And I just need to add the exponents, 1 plus 2. For the q's, notice I have a like base here, keep the same like base of q, and then add 3 and 3. So I'm going to get q to the 6. I'm going to get x, 1 plus 2 is 3. Now notice these are not like bases. There are my coefficients. So what am I going to do with them? Multiply. 4 times 3 is 12. This is my final answer. Let me do maybe 1 or 2 more of these, because in case you got lost here, more practice will help. So let me write another one up real quick. Just to practice. I think just this one more will help. Again, this is just the same directions. You want to simplify, use your properties. You could use associative and the commutative property as well, besides the properties of exponents. So our first step, see what your bases are. So each exponent that you have, see what it applies to. So this 2 only can apply to the a because it's the first thing it touches. It cannot apply to the 5. The only way this could apply to the 5 is if it hits a set of parentheses first, and the 5 was in that set of parentheses. The first thing this hits is the a, it can only apply to the a. Notice this y does not have an exponent. Anytime that you see a variable that does not have an exponent, slip in a 1. This 1 only applies to the y. So this is a separate base from this. Over here, that's a coefficient, so I don't have to worry about that. This only applies to the a, so that's a base. This applies only to the y, so that's a base. So you can see 5 and 6 are coefficients, not bases. So we can separate them because we're only doing the product rule, so we're allowed to separate them. This and this, because they're the same base, we don't have to write a twice. We only write it one time. A, keep the same base, a. Just add the exponents. 2 plus 4. And then y, keep just one base of y. Add the exponents. 1 plus 3. So when I add, 2 plus 4 is 6. Y, 1 plus 3 is 4. And this, the two coefficients, remember, multiply. Okay. All I did was follow these steps here. I kept the same like base once I realized I was multiplying like bases. Kept the same base, added the exponents of the like base, and then multiplied any coefficients.